What's that?
I skipped over it at first, but that's
You went back?
yeah.
What? I don't know. No. Hi, Hope. We're going over the test. Where is Hope? I don't know. Hope, where are you?
That's weird.
Okay. All right, so it's important to note that everything they tell you, for the most part, like 98% of the time, is important. So, a lot of times, like on the HESPAs, if when you took the HESPAs, you ignore a lot of the initial stuff, but it's actually really important to note that g of x is bigger than 0, and that f of 0 equals 1. Okay, it's not important at first, but it is important eventually. So, if h of x is blah, 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 and h prime of x is f of x, g prime of x, then f of x equals what? Well, here's h of x, it's defined as that. I can't just go and say, okay, well this is the derivative of h. Like that's what they're telling me it is, but I also know more than that. If h of x is made up of two things multiplied, what do I really have to do to find the derivative of it?
Product rule.
Use product rule. So if I really wanted to find the derivative of h, I needed product rule. So I would have done the first function times the derivative of the second, plus the second times the derivative of the first. This is the derivative of h, but they're telling me this is. Well, if this is the derivative of h, this is the same thing as this part. That means this must equal 0. Because if h of x, or if h prime of x is the product rule using this, but they're telling me h prime is really just this part, well then this is true. It still exists. It's a part of the derivative, but it must equal 0. So I know that g of x times the f prime of x equals 0. Does that make sense first? Without that, you can't do the problem, and that's like the biggest difficult part. Okay, so I'm there first, and that's why these tests are so freaking annoying, because you have to be so creative. Well, I'm here. Well, they told me g of x is greater than 0. Not greater than or equal to, but greater than. Well, if g of x is bigger than 0, what's true about the derivative of f? It equals 0. Because if these two things multiply out to 0, and this one's bigger than 0, well then f prime of x is the one that equals 0. Because if the other one's like 4, it's bigger than 0, the other one had to be 0 for them to multiply out to 0. Get that? Maybe? Okay? So now I know that the derivative of f is 0, but they want to know what f is. And at this point I had to go to my choices, because we don't know how to integrate, and it doesn't even matter, but now I have to go to my choices. So they're saying f of x equals what? Well, I kind of went to my last three to see if they could give me anything that makes sense. And it makes sense that if f of x, equals 1, what's the derivative of 1? 0. So my derivative is 0, my original function then is 1. None of the others would have worked.
Well, 0 would have, but then it would have made the other side of the equation 0.
True, from the very beginning it would have, right, true. G or D would have worked, but then f of x would have been 0, and then this whole thing would have fallen apart. And, true, and f of 0 equals 1. Forgot about that. And f of 0 equals 1. So that is actually important. So f of 0 equals 1. So for f of x, if f of 0 equals 1, and the derivative of f is 0, that has to look like that. Sorry, forgot that little part. Get it? Yeah, it's not easy. I'm sorry. Okay, what else? Number 1, everybody should have gotten, because if you had the things memorized, it's easy. Number 2, you really should have gotten. Number 13. Okay, where is it not differentiable? We should have known it's not differentiable at points of discontinuity, and it's not differentiable at vertical tangent lines. So I felt like that one was a giveaway, because they even said there's a vertical tangent line at the point 2, 0, so like, hello, not differentiable there. They were trying to kind of give it to you. 14 also shouldn't have been too bad, and I'm not trying to be like, you got it wrong, so you're an idiot. I'm just trying to tell you which ones are really tricky and which ones aren't as tricky. Questions on 14? 16 also, not too bad, it's just derivative with chain rule. So if you made a mistake there, it was probably just a silly one. Same with 28. If you made a mistake, it was probably just a silly one. 26, very difficult. In my book, it tells me like what percentage of people get each one right. So that one was like a really low percentage. So I don't remember what it is, but a very low percent of people get this problem right. But here's the idea. The function f is continuous on the closed interval 0 to 2. So that means that there's no breaks in the graph, and that's important. And it has the values given above. So when x equals 0, the graph's at 1. When x equals 2, I'm up at 2. And when x equals 1, I'm somewhere at k, and they don't tell me where. But they do tell me it's continuous, so I know that like from 0 to 2, this whole thing's connected somehow. Okay, the equation f of x equals 1/2. Well, what does that look like? What does y equals 1/2 look like? Horizontal line at 1/2. The line y equals 1/2. So that's the line f of x equals 1/2. It has two solutions with this function if k equals what? Solutions means intersections. Solutions means that's how many times this graph and this graph are going to cross. That's a solution. So what does k have to be so that if I connect this to this and I go get k first, I cross this twice at least. K's got to be somewhere down here so that I can draw this and back up, and I have two solutions, 1, 2. So k has to be something that's smaller than 1/2, and your only choice is 0. K doesn't have to be 0, but if k were 0, I would have two solutions. Do you get it? A simple, simple problem with a very complicated way to interpret it. Okay, keep going. 23 was not easy. If you put E, you were like a millimeter away from getting it right. E would have been the next best choice for the last no calculator problem.
So how can you get a straight line?
How can you?
Yeah, from that graph.
You can't, but that's why it's wrong.
Yeah.
I'm just saying it's like the next best choice. Anyone want to go over 23? No. Okay. All right, next section. Number 76, I made up, and I couldn't find one on these tests that I was taking it from. That was supposed to be another gimme if you knew the procedure. It's crazy easy. If you didn't know the procedure, it's hard. Yeah.
If there's like 3 points of intersection, how do you know?
So I need to talk to you because I gave all of them a clue that I didn't give you. You got it right? Then you're good. I had put on the board, use the whole number answer, not the decimals. So that's what.
Yeah, I just used one.
And only one worked? Okay. So yeah, sorry about that. 78, very difficult. Do you want to go over 78?
Yeah. Actually 76, I got it right, but I just guessed, so I don't know how to do it.
Okay, 76. I'll just go through the procedure again. Take f of x, and you got to set it equal to -3. The idea here is, so this is what I'm trying to find. This is a derivative of an inverse. This is an x value for the inverse, but it's a y value for the original.
Yeah.
So I got to go to the original and set it equal to -3 and find the x that goes with it.
Yeah, I got that.
Okay, so I got x equals 1. I actually got 3 answers, but 1 is the only whole number. Then take the derivative of f and plug in 1. Whatever you got from the solution up here, plug that number in. I got -4. To find the derivative of the inverse, take the derivative of the original at that spot and flip it upside down. -1/4. So it's just a procedure to remember. Okay? I mean, we went over y, but at this point, like if you don't quite get y, just remember how to do it. Anyone want to go over 78? Okay, 78. You're gonna you'll understand. It's just really tricky. Okay, the radius is decreasing, so dr dt is decreasing, so it's negative 0.1 centimeters per second. In terms of the circumference, what is the rate of change of the area? So we're being asked to find dA dt. Hopefully you got to that point. Okay, they tell you how fast the radius is changing, you want to find the rate of change of the area. So I need a formula that connects area and radius of a circle. So area equals pi r squared. The bone that they throw in here to make it confusing is they bring circumference into it, and you're like, how am I supposed to connect circumference with this? Well, if you kind of ignore that at first and say the area equals pi r squared, and go take the derivative of this is going to be 2 pi r dr dt. What is 2 pi r? Circumference. So what they wanted you to see is that dA dt is the circumference times dr dt, which they give you as negative 0.1. So dA dt is negative 0.1 times c. I think it confuses you right up from the start because you don't know how circumference plays into this until you go take a derivative and can maybe see, oh, that's circumference. I can replace 2 pi r with c. When you look at the answers, it kind of helps you a little bit to lead yourself there, but that's about it. 87? You want to go over 87?
Yes.
Yes.
Which of the following is an equation of the line tangent to the graph of this at the point where the derivative is 1? Okay, so we're looking for the equation of a tangent line. Anytime we're looking for the equation of a tangent line, we need a slope and we need a point. We have the slope. They're telling us the slope is 1. They're telling us the derivative is 1. So I know that, but I don't know where. So to find where, my f of x is this. I have to take the derivative of f and set it equal to 1. And that's going to tell me the where. So try to think about, if they're asking where, they're looking for an x. If they're asking for a slope, they're looking for a derivative and plug stuff in for a derivative. So I'm looking to find out where does this happen so I can write an equation of the tangent line. So since the slope is 1, I set the derivative equal to 1 and I solve it on the calculator. On the calculator, I get x is 0.2367. I want to find the y that goes with that, so I plug that back into the original and get 0.1151. There's my x and y point, and there's my slope. And then just using the point slope form, I put it all together. I do. I graphed this, and I graphed 1, and I did intersect, and I got that x value. And put that into the original, get the y that goes with it. And then I'm doing y minus the y equals slope times x minus the x. And then get it in the form that they wanted. If you put a, you're definitely way wrong. So at least you should know the slope was 1, so it would be b through d, or b through d.
Pretty good guesser.
Yeah?
I have a circle on my paper, but I wrote the right answer.
That's very good. How about number 90? Okay?
Yeah.
90, again, you're going to say, all right, I get this. Like, it's just getting it at the test time. So in general, the base of a triangle is increasing and its height is decreasing. So dB dt is increasing at 3 inches per minute, and dH dt is decreasing at 3 inches per minute. And what must be true about the area? Okay, well, we know the area is 1/2 base times height. So when I went and looked at my answers and it says what's true, A is always increasing, or A is always decreasing, or A isn't decreasing only when blah, 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 blah. I know I'm talking about a rate in which A is changing, so I want to go find dA dt. Okay, I'm trying to figure out at what rate area is changing, so I'm going to take the derivative. So I take the derivative of this, I'm going to use product rule. I'll have 1/2 b dH dt plus h times 1/2 dB dt. From there, I just plugged in dH dt and dB dt. I think I took out a 1/2 because it didn't really matter. So dH dt dt is negative 3. dB dt is 3. So I have that. So the rate of change of the area is 1/2 times this. Well, if the area was always increasing, what would be true about all this? It'd be positive. Okay, if the area was always increasing, then its derivative would always be positive. But it's not going to always be positive. If the area was always decreasing, the derivative would always be negative. But it's not always negative. So that leads me to choice C and choice D. So choice C, A is decreasing only when B is less than H. I just plugged something in. I was like, all right, what if B is 1 and H is 4? And that turned out not to work. Then I tried it the other way, choice D. What about when B is bigger than H? So I plugged in something, 2 for B and 1 for H, and then it gave me a negative number. So I had to kind of guess and test a little bit, but that's about the only option that you had. And then choice E, A remains constant. No, you got 2 variables in it, so it's not going to be constant. Open-ended? Okay. Find UIDX. I really did not realize that this was going to be such a difficult part A. I think people just got, like, going too fast or whatever. I really do believe you know how to do part A. Do I have to do A, or do you know what you got wrong if you messed it up?
I know what I'm.
Write it out.
Write it out. All right. So we got 6y squared, y prime, plus I need product rule for that. So I'll say 6x squared times the derivative of y, plus the y times the derivative. What?
Oh my god, this class is huge. Can I get my book?
Michael!
Yeah.
No. Whoa.
So I end up with all of that. First term, and then this is the product rule for the second term, 24x, and then the 6y is 6y prime. And maybe I think people got that wrong. Either didn't have the y prime on there or had a y and a y prime. That's not right. I'm going to take everything that does not have a y prime in it to the other side, and I end up with, whoops, a 24x minus a 12xy over, when I factor that out, a 6y squared and a 6x squared and a 6. That would have been fine as an answer. You also could reduce out the 6's, and that would have been fine as an answer too. So if you got that wrong and you don't understand why, let me look at your work, because it's something algebraic that you're screwing up, and it could probably be easily fixed. Is that okay? That was worth a total of 2 points. Every open-ended is 9. Okay, that's worth a total of 2. Part B, write an equation of each horizontal tangent line. Okay, so you've got 1 point, and most of you got it, for setting this equal to 0. So part B, write the equation of each horizontal tangent line. So you have to set this equal to 0. Okay, well, setting this equal to 0, we don't care about the bottom, because to make something equal to 0, we care about the top equaling 0. So when I do this, and I take the x out, whatever, I'll take 12. I get this. So when I set the top equal to 0 and I factor out a 12x, I get this. Well, this tells me x can be 0 or y can be 2. Those are my two, and y can be 2. Those are my 2 solutions. Do you understand that part? Okay. Well, they want me to write the equation of each horizontal tangent line. Well, I have 2 things. X can be 0 or y can be 2. Don't get duped, and I got duped. Y equals 2 doesn't work. You got to go back and check it. You have to go back to the original problem and plug in y equals 2. When I do that, just trust me, you end up getting 28 equals 1. Like the x's cancel and stuff cancels out. I end up getting all of my variables dropping out and 28 equals 1. That's not a solution. It's a faker. So that's going to happen every once in a while. If you go back and you test that, it doesn't work. If I go back and plug in x equals 0, I got the y to go with it. It was 0.165. That is the equation of the horizontal tangent line. Horizontal tangent line is just y equals the number. So since the point is 0.165, the horizontal tangent line is y equals 0.165. This section was worth 4 points. 1 for setting that equal to 0. 1 for doing the math and getting these two solutions and crossing this one out. And then 2 for getting this answer. I put into the original. So think about, like, when I want to know where is there a horizontal tangent line, I'm setting something equal to 0 and I'm solving it. Well, I want to know what goes along with that x. So I plug that into the original to get the y that goes with it. Yeah. With a calculator. Yeah. Yeah.
Say we screwed up in the first letter. Will they accept our answer?
It depends what you did. This one was a tough one to give many points for. They'd still give you the 1 for setting it equal to 0, even if it's the wrong thing. But beyond that, no, because if you went and plugged it back into the original, it wouldn't have worked out. Alright. Part C is just crazy. Part C, the line through the origin with a slope of -1 is tangent to the curve at point P. Find the x and y coordinates of point P. What does the equation of the line look like if it goes to the origin and its slope is -1? Y equals -x, right? You got 1 point for figuring that out. You were supposed to take this and solve it simultaneously with this and get your x and y coordinate. And that's all they wanted. Take that, basically plug the y equals -x in for all the y's, and get the x coordinate of -1/2, and then the y that went with it is 1/2. The other thing you could have done was set the derivative equal to -1. Some of you did that, you got a point for it. But then from there, you still had to substitute this into the derivative and solve it from there. That's for everybody. I don't think anybody got this and substituted it into anything to get this. And that's where those 2 points are really hard to get. Okay, because class is almost over, don't you think you want to practice a couple more problems like this?
Thinking of a test.
You just want to call it a day?
I want the problems.
Yeah, because you were doing
If you want to take anything, you're more than welcome.
I already went over all
We
of
can just
this.
deal with it tomorrow.
I'm working on the next chapter
We'll deal with it tomorrow. That's fine.
Why would you roll that in?
because I want to get great on the next
Why
test.
do it today?
Because Zach is determined.
I'm getting 100 on the next test.
100.
Unquestionably.
Give him
It's
a
good.
second option make test that's much more.
Not very well.
It's like
What's that?
Unreasonably
Oh, I want
well.
the test back when you're finished. I do want them all back, answer sheets and everything, but if you want to keep them for a little while to go over it, that's fine with me. So, put them in a big pile if you don't want it.
You have water.